And possibly this is misguided. So in our data we see that explanatoriness is actually a multi-dimensional thing. So it seems to be located at the conjunction of 3 dimensions. So here's the loadings for explanatoryness. Seems to have little or nothing to do with aesthetics. Negatively related to intricacy, positively related to precision, and weakly positively related to utility. So maybe, if this suggests anything, it suggests that proofs which are not intricate, precise, and useful have a chance of being called explanatory. And that seems to be quite different to these single characteristic accounts, because it seems to require 3 different properties in order to be explanatory. Now this is where I report Andrew's idea to my non-philosopher status comes through clearly. So I hope no one asks me difficult questions about this. But this guy, Khan, apparently distinguished between explanation and explication. Okay. And that should be explication, really, shouldn't it? Okay. Oh no, it shouldn't. Sorry. Well, I need Andrew in the audience to help me out in this situation. Okay. Explanation is a relationship between a factual natural phenomenon and its explanation. Explication is the process of clarification or conceptual analysis. Is that right, philosophers?
Depends.
Okay. Alright. So here's Kant. Good explication should meet 4 criteria. It should be similar, the explicatum should be similar to the explicantum. That's important. But it should be characterised in an exact form, it should be a fruitful concept, and it should be as simple as possible. So that's what Kant says. Right, so if you think about those things, exactness, fruitfulness, and simplicity, and translate it into our dimensions, good explication should be precise, useful, and not intricate. And in fact, that's what we got on our loadings for explanatoriness. So this is Andrew's big idea. Maybe in mathematics, mathematical explanations are just explications. And that seems to have some empirical support from this data. But as I say, I hope there's no questions about that. Okay. So I'd like to make some claims about implications for mathematical practice research. So what is mathematical practice? Well, understanding mathematical practice is really just a claim about how mathematicians behave in mathematical situations. That's all it is, really. And a very, very well-established finding in psychology is that experts are awful at introspecting on the nature of their expertise. So there's tons and tons of literature on it. You know, if you try and get a basketball player to say why they're good at basketball, they've really got no idea at all. The classic example you've probably heard of is those people who go and determine the sex of newborn chicks. You know, they can do this with enormous accuracy, but they have no idea how to. So we really mustn't trust introspection. And then, as I said, there's really a lot of literature on that. And you can see it again here. So many mathematicians apparently, including Crankbury, very clever guy, thought that beauty is about simplicity. But apparently it isn't. You know, when you actually find out how these words are used, have no relationship at all. So that's sort of hopefully a more evidence version of the rant I gave at the last conference. I'll let other people judge that. Okay. So how can this, what's the point of all this? Well, we've just finished testing a very short scale to sort of measure, in inverted commas, these things. So we had our only 4 items per dimension, and we got quite high internal reliabilities. So normally when you develop a psychological scale, you look for an alpha value of 0.7 or above to show that it's internally reliable. So the things on that scale are measuring the same thing. And we have that now on our short form personality scale. That's what it looks like. And it only takes a couple of minutes to fill in. So what might that be useful for? Well, here's some example research questions that maybe it may be useful. So one participant in this study emailed me after, got very excited about this, and she said, well, look, I think that mathematicians perceive women's proofs to be less aesthetically pleasing than men's proofs. And she was obviously very het up about this. I don't know, she didn't explain to me the background as to why she thought that. But this would be a very straightforward study to conduct. If you have an easy, if you have an instrument that's straightforward to use to measure, in inverted commas, the perceived personality of a proof. You just simply change the author and see if it changes the perceived personality. I think this is an interesting question. To what extent are personalities a property of the proof? And to what extent are they properties of the mathematician doing the judging? I have no real insight into that question. And are there systematic differences in judgments between different research areas? So I think Brendan did a talk at Alison's conference a few years ago where you suggested, in some sense, the argumentative patterns sort of defined a single discipline in some sense, if I remember rightly. You weren't really talking about this, but I guess it's a similar kind of idea. Is it the case that these judgments about mathematical quality are the same across all areas of maths?
But is that generally the case?
I have no idea, it's an empirical question. Find out. So, as to conclude, this is the claim I'd like to make. Mathematical proofs have personalities in some sense. Roughly speaking, they're four-dimensional. Frank Gray and others are barking at the wrong tree when they suggested that beauty is related to simplicity. One possible account of that is simple proofs are easier to remember. And I think there's good reason to doubt Rota's and McAllister's characterisations of beauty. But I don't want to, I'm big about my fair on McAllister, I think. So, that's the end of that. Thank you.